Hello everyone, today I'm going to be talking about metabolism. So metabolism can be broken down into two main categories. You have catabolism and anabolism. Catabolism is the breakdown of larger molecules into smaller molecules, allowing for the release of energy, whereas anabolism is the formation of larger molecules from smaller molecules. Now this makes catabolism exergonic, whereas anabolism is endergonic. Relating this to delta G is free energy, expression that shows the change of energy over time in a reaction. Delta G overall is the final amount of energy in a reaction minus the initial amount of energy in a reaction. So, as you can see by this first graph here, the reaction starts out with more energy and ends with less energy. This means that the final minus the initial is going to be negative. Delta G will be less than 0. If delta G is negative, then the reaction releases energy or loses energy, which is how you can think of it as a negative, and this causes it to be exergonic or spontaneous. In this other graph here, we see that the reactants have a lower energy level, and the products have a higher energy level. The initial amount of energy is less than the final amount of energy, so final minus initial is going to be positive. F being final, and I being initial. In case of the endergonic reaction, you're going to have positive delta G, meaning that the reaction is not spontaneous, and it is endergonic. These are a couple different types of delta Gs. The main ones that we're going to talk about are going to be delta G naught, which has this little circle, and delta G naught prime. Delta G itself is also very important. It's the actual measured free energy of a reaction. So if you take a reaction, just measure it in real time, that's what you get. Delta G prime is going to be the free energy of a reaction at standard state. Standard state means a couple different things. It means that temperature is held at a certain point, that pressure is held at a certain point, and that the amount of reactants and products are held at a certain point. Other delta G naught prime, is also at a standard state, but in addition, it is at biologic conditions, which refers to pH. So this one is going to occur generally at pH 7, and it's indicated by this little tick mark here, which makes it delta G naught prime. Another important thing to understand is activation energy. So activation energy is the amount of energy it requires to actually do the reaction. So if you see here, the reactants start out with less energy. This is an exergonic reaction. It's going to have a requirement of energy to get this reaction started. It's kind of like if you're pushing a boulder over the hill, you have to kind of put some energy in, and then the boulder will just go down by itself. So you think about, physically, you can look at this graph here and be like, could I push a little thing up this hill and then boom, it would roll down, kind of a situation. That's a good way to think about it. So once again, for this reaction, your overall energy change is going to be negative. You're losing energy, you're exergonic, you're spontaneous, but this activation energy is still required. And what makes activation energy interesting is that it can be modified by enzymes. So enzymes are proteins that like I said, modify or lower activation energy for reactions, encouraging them to happen and encouraging them to happen quickly. This is kind of what enzymes do for a reaction, is they'll bring in a substrate and then create enzyme substrate complex, and then the products or product will leave. This can either go this way or in reverse. You can have two things turn into one. There's many different ways that enzymes can function. But of course, a substrate is just compound that this enzyme interacts with. So more on enzymes. The active site of the enzyme is where the substrate binds. So that little divot in the enzyme before, that's where the substrate is going to bind. Enzymes may have non-protein regions. So these can include something like the prosthetic group, which is a molecule that's always bound to the complex, and kind of allows the complex to function in a certain way. Coenzymes are non-protein molecules that interact with the enzyme, but not all the time. So they may bind to the enzyme and allow it to actually function, or they may bind to the enzyme and prevent it from functioning. They're basically a regulator of the enzyme's activity. So this is a graph of how the energy change in a reaction will differ with versus without an enzyme. So without an enzyme, you have a lot of activation energy. It's less likely to happen because of all this activation energy. But with the enzyme, the activation energy is a lot less. It's important to note that the delta G does not change, because remember, delta G is just the energy change from the reactants to the products. It's final energy minus initial. So in this case, once again, we have an exergonic reaction. The final energy is less than the initial energy, but this does not change at all with the enzyme. The enzyme only can speed up a reaction and lower activation energy. Quick mini review. Does delta G change when an enzyme is added to a reaction? Pause the video here to answer. No, but activation energy is lowered and the reaction does speed up. So it does not change delta G.